Welcome, everybody. My name is Doug Gould. I am a professor and chair of the Department of Foundational Medical Studies at Oakland University William Beaumont School of Medicine. We're located outside of Detroit, about 15 miles or so north of Detroit. So I've been doing this, I think, for about 6 or 7 years now, usually face-to-face. This is my first time doing it via Zoom. I have mainly do administration right now, but I still am very active in teaching neuroanatomy to our first and fourth year medical students here at OUWB. So I have you for quite a while today, and my task from the folks on your end there, Michael and his crew, is to focus on some neuroanatomy. So the way the day is divided up roughly into hour-long chunks, and we'll start out discussing the basic anatomy of the peripheral nerve, and then move on to the central nervous system. We'll have a little break, and then we'll go ahead and talk about the motor and sensory systems from an anatomy standpoint, leaving a lot of the physiology and pathophysiology and pathology and such to the much more qualified folks coming after me. I'm going to lay the groundwork, the anatomical groundwork for things. And then after we have a little lunch, we will move on and talk about the visual system, anatomy, the auditory and vestibular system, neuroanatomy, and then we'll finish up talking about the anatomy of the limbic system. So if you have any questions throughout, please type them into the chat, or I think you have the ability to raise your hand. I have the chat box up, and we'll do my best to respond. I'm not a Zoom expert, probably any more than the rest of us are now. I guess I'm more of an expert than I was a few months back, but welcome, and I hope this meets your needs and your expectations. So let's not waste any time. Let's go ahead and start talking about the peripheral nerve. Peripheral nervous system in general, I should say. So the goals are, we're going to trace some of the components of peripheral nerves, what's in those nerves. We'll identify some of the big plexuses. I think I really like to focus on one representative plexus and then discuss the concept of the other plexuses. So we'll just do the brachial plexus, which most of us have pretty good familiarity with. We can spend a lot of time talking about the cranial nerve. So I'm going to try to go over the anatomical components of those nerves, what's in the nerves, and then a very basic overview of what they do, trying to focus on an anatomical perspective again. We will talk very briefly, like just a slide or two on myelin. Then we're going to differentiate from a peripheral nerve, a pattern of innervation versus a dermatome, a pattern of cutaneous innervation. And then we'll talk a little bit about referred pain. So that's the peripheral nerve outline. I'm really big on emphasizing that nerves are, I know it's very easy, especially after you practice for a while, to start to say this is a parasympathetic nerve, this is a motor nerve, this is a sensory nerve. From a neuroanatomical standpoint, they're nothing more than tubes. I use the analogy of a conduit of PVC piping. We care what's inside the pipe. We care what's inside this conduit, really not trying to label the conduit per se, like this is conduit for hot water or cold water, or this is motor or sensory. I'll give you an example of why. Most people refer to the vagus nerve as a parasympathetic nerve. It's not. The vast majority of its fibers are sensory fibers. So if anything, I'd call it a sensory nerve, but most people would say the vagus is parasympathetic. I get it. That's because some of its key features are parasympathetic in nature, but I'm going to try my best to convince you to think of them otherwise and just worry about what's inside them. So the basic definition of a nerve is it's a collection of axons outside of the central nervous system. There's two types, really. There's cranial nerves and spinal nerves. They are pretty much the same animal. The only difference is that the cranial nerves happen to come off the brainstem or the undersurface of the brain. the spinal nerves, 31 pairs of them, one pair for each spinal cord segment, come off of every level of the spinal cord. So every level of the 31 spinal cord segments has a pair of spinal nerves coming off of it. And then, of course, we have the 12 cranial nerves. And they can be myelinated or unmyelinated, and we'll take a look at that here a little bit later as well. So let's look at what can be inside of a nerve. So this is a basic outline here. This is the spinal cord cut across section here in the upper left. This would be your anterior root and your posterior root, or you can call it ventral root and dorsal root. This little thing right here, no more than a centimeter or so, is the spinal nerve. And that terminates by dividing into an anterior ramus or an anterior branch and a dorsal or a posterior branch. I try to use ventral and dorsal. I'm pretty well trained to do anterior and posterior just due to our bipedalism. I know that our dorsum this is most commonly called a dorsal root ganglion right here. I prefer to call it a spinal ganglion, but we'll make sure that everybody's on the same page with the terminology. The other thing on this picture that's interesting, first of all, I know that it's between T1 and L2 spinal cord levels. I know that because it has a lateral horn. The lateral horn only exists between T1 and L2. The lateral horn houses the preganglionic sympathetic cell bodies, and we'll talk all about those a little bit later when we do the motor system. As I'm at L2, if I come out here, I can see a couple of connections and a couple of other masses of fibers down here. Let's see if I can use this instead. Right here, I see in a white rami communicans. Here's a gray rami communicans right here. And I'll see I've labeled L2 and L3. These are levels of the sympathetic chain or paravertebral chain, whichever you prefer. Some people call it sympathetic trunk. They're not numbered in a 1-to-1 ratio with the, where'd my cursor go? Shoot, I lost my cursor. There we go. Back to mouse here, here we go. So this is L2 spinal cord level. This is probably somewhat close to it. So I've drawn a little abstracted hunk of sympathetic chain here for you. This right here is a prevertebral ganglion. This would be an accumulation of sympathetic postganglionic cell bodies that we typically find on the aorta right here. And this is some, I don't know, just random sampling of gut. Okay, so that's all going to make sense here in a second. Let's color in some things. So we know that our somatic motor neurons are in the anterior horn of the spinal cord. Somatic motor neurons. These are the voluntary motor neurons that will control skeletal muscle, for example. They send out a fiber. That fiber, that axon, comes out the anterior or motor or ventral root, whatever is your preference to call it. They enter into the spinal nerve. The spinal nerve terminates by dividing into an anterior ramus and a posterior ramus. So this would come out to your biceps brachii or your quadriceps femoris or some your latissimus dorsi. It would become a nerve. This will go to the muscles of the back. These will be to the true back, the back part of your trunk. All of the limbs, your upper limbs, your inferior limbs or your lower limbs, the whole anterior aspect of your trunk, most of your trunk, your head and your neck, well, I shouldn't say head and neck, certainly your neck, are done by anterior rami branches, which are mostly named nerves of the body, right? Likewise, we're all familiar with the somatic sensory neuron or somatic afferent located here in this structure, which is our dorsal root ganglion. You can label that, or spinal ganglion. We know that this is also, we'll talk about this when we do the sensory system, called a primary afferent neuron because it's the first neuron in a 3-neuron chain that conveys sensation into the central nervous system and up to the cerebrum, up to the cerebral cortex. And you see its fibers coming in from the anterior aspect of the body wall, the lower limb, the upper limb, and from the back. We have those in orange. The fibers come in. The cell body is located here outside of the central nervous system, and it projects its central process in to the posterior horn or dorsal horn, where it'll synapse on a secondary afferent and do some other wonderful things we'll talk about later. So that's pretty straightforward, but now looking at my spinal nerve, I have a couple of different fiber types in here. I have somatic motor and I have somatic sensory, right? If I add in a new animal here, this is the visceral afferent neuron. So that's interesting. So these sensory cell bodies for the body wall, as well as from the viscera, and the viscera being the hollow organs of the body, are both located, the primary afferents are both located outside the central nervous system in a ganglion. And that rule is true for everything except for one little bit up in the head that we'll talk about when we do the trigeminal system. But every sensation from every part of your body, that first neuron is located outside the CNS. And for the body, it's in a dorsal root ganglion. We see we've colored it in green. But you can see they're housed in there with the same neurons. This is going to create a problem we'll talk about when we do the sensory system. I shouldn't say it's a problem. It's going to create the one form of referred pain. Here's that little hunk of organ. Let's say it's the stomach. It sends its fibers up from the stomach. They're going to ride along blood vessels, pass through this ganglion, this prevertebral ganglia, which we find in the aorta. It's not going to synapse or anything. It's going to pass through the sympathetic chain. It's going to pass up through the white rami communicans and enter into our spinal nerve, go through our dorsal root, and synapse on cells in the dorsal horn of the spinal cord as well. So now I have three fiber types here in the spinal nerve. If I'm coming back from the gut, not all spinal nerves have to have all these fiber types, but if I'm coming back from the gut, I'm going to have visceral afferents in there as well, right? That's an interesting point that I just made, and kind of breezed over it, but we should linger there for a second. Not all of these nerves are going to have all of these fiber types. This is just what's possible to have in a nerve for right now. There's the preganglionic sympathetic neuron that I mentioned a minute ago, and that the presence of that column of cells, and I'll talk all about the concept of a column of cells in a minute or a little bit later today, is what forms the lateral horn. And we call that column of cells the intermedial lateral cell column. Now those fibers are motor, right? The autonomic nervous system is a motor system. One of my pet peeves has always been, and I learned it this way when I was in undergraduate, that the nervous system has three parts: a peripheral nervous system, a central nervous system, and an autonomic nervous system. That's terrible way to divide the nervous system, because the peripheral nervous system and the central nervous system, that's a structural way to divide the nervous system. It's either part of the brain or spinal cord, or it's not. That's structural. The autonomic nervous system is part of a functional way of dividing the nervous system. There are parts of the autonomic nervous system in both the central and peripheral nervous system. So that's a functional way to divide the nervous system. Its component part would be the somatic nervous system. So I would divide it into CNS and PNS, or you could divide it into somatic and autonomic. One's functional, one's structural. Okay, so this is part of the motor system. These are motor fibers. Yes, there are visceral afferents. We just drew them in, but they're not part of the same system. They often ride together, but one's sensory and one's motor. So if fiber comes out the same motor root or anterior root like we would expect, or ventral root, but in this case, notice it does not go out to the periphery. It doesn't go out to any sort of a target. What targets would be in the body wall? These would be going to the body wall out here, like the lower limbs or the neck or the true back muscles, the back. What body wall targets would possibly need autonomic innervation? Well, there's three. There's three targets in the body wall: blood vessels, sweat glands, and erector pili muscles for goosebumps. Those three things are under autonomic control. And more specifically, those three things are under sympathetic control. We're going to talk all about the autonomic nervous system in a little while. So the sympathetics, but they don't go out here.